Motors and machines drives the industries. Let's say there is a packaging machine which is working day in and day out. This machine and motors requires maintenance and parts replacement based on various faulty conditions. This may require significant amount of downtime, which might cost a lot, even in millions, within few hours. But with the help of predictive maintenance, with machine learning, we can reduce or even totally eliminate the downtime. Just imagine how it is helpful if the system itself can alert us for the brewing problem while the machine is still in running state. So this is the generic high level workflow that every machine learning based project is following to implement a machine learning application. There is two parts. One is done by the data scientist and machine learning engineer, and the right side by machine learning application developer. In this left part, sample dataset is the prerequisite for the data scientist. And after getting the sample dataset, the data scientist will do the pre-processing, do the cleaning of the data and make it suitable for a machine learning model. After the pre-processing, the final training dataset will be ready for feeding into the machine learning algorithm. Here we have to decide which particular machine learning algorithm we need to use based on the data and the requirement. So after going through the machine learning algorithm, the machine itself will learn and capture the pattern within the data, and we can also test the accuracy after doing the machine learning. So if the accuracy is not satisfied, then again the machine learning engineers will tune the parameters and make the final training dataset to fit into the machine learning algorithm. After the machine learning algorithm will identify those patterns and build the custom machine learning model, it will be ready for the machine learning based application for further consumption. So at this point of time, we are ready with our custom machine learning model. Now it's time to build the application on top of it. In this application, we'll simply give the input to the custom machine learning model to predict our output. Now let's come to the actual implementation part. So here in this project, you can see I'm using ml_data.csv file where I have my sample training data set. Let us first understand the sample training data set. So here in the sample training data set, I have multiple attributes. First attribute is voltage or current supply, then continuous running time of motor, then average speed of motor, motor vibration, total weight of goods packed, and temperature of the motor. So based on these attribute values, we have seen the motor fail or motor not fail in the past. So with these values, we have seen the motor is going to fail, and with these values we have seen motor is still running in good condition. So 1 means fail, 0 means motor running still in good condition. We'll be using the data for our machine learning training. So here in this ml_training.py, we'll be giving this input to our algorithm and we'll build our custom machine learning model. So this model.pkl is our custom machine learning model. So now I will be again doing machine learning training. So that's why I'm just deleting the machine learning custom model. So again, I'm going to this machine learning training.py. Here in this program, you can see I am importing different libraries like NumPy, Pandas, and the very important one is the logistic regression from sklearn.linear model. And then I'm loading the data from the CSV file with using the Pandas read CSV, and then I'm using the NumPy array to format the data, dividing the data into two parts. One is the input, probable input, and second one is the probable output. So X is the probable input, Y is the probable output. So here this will be considered as X, that is the probable input, and this will be the probable output. Then I'm converting into the integers, and now we have to split the data set into train and test. Here you can see I put 30% of the data set for my testing purpose. Now we are initializing the logistic regression, and now with this logistic regression I'm giving the feed of the data, that means the X train and Y train data, into this logistic regression algorithm. After feeding the data into logistic regression algorithm, here only we are asking the algorithm to learn by itself and find the pattern of the failure or not failure. Measure the accuracy part here with using the logistic regression dot score. Here we have to pass the test dataset that we have already segregated in our previous step. Here you can print the score to get the accuracy. Then here in this program itself you can test out with your sample data and get the probability. Now it's time to generate the custom model and put it into a pickle file. With using this pickle.dump, you can write the model into this .pkl file. WB is for the write. Now we'll execute this ml underscore training.py to generate our custom model in pickle file. So I'm going to the terminal. I will be using python ml underscore training.py. Enter. So here you can see one model.pkl file has been generated. Now we'll be using this custom model in the actual application's web server. So in this actual application, we'll be getting the user input from a HTML form and pass it into this custom model to get the predicted output. This is our actual application web server app.py. So here in this application you can see we are importing certain libraries, the Flask, Pickle and NumPy. Flask is for the web server, and then Pickle will be using for reading the custom model, and NumPy is for formatting purpose. Here you can see we are loading the custom model in read mode, and then this is the default route which will call on HTML file, that is machine underscore bread.html, and which will be called from this templates. Here you can see this is the HTML file. Let me go back to the app.py web server. Here we have another route, that is the predict. When this route will call, it will get the data from the form and it will format into the integer values, and then with using numpy array we are formatting it and then passing it to the custom model to get the prediction. After getting the prediction, we are formatting it into 2 decimal values, and at the end we are adding a condition. If the predicted value is greater than 0.5, that means 50%, we are saying machine is in danger. If the predicted value is less than 50%, we are saying machine is safe. So now let's go to the HTML file. So this is the particular form, and when the form will be submitted with using the submit button, you can see this predict route will be called with the inputs that the user will be giving it here. Let's run the web server. The web server is running in this particular port. Let's test the application from the browser. Voltage 100 volt, continuous runtime of motor 180 minutes, average motor speed 1200 rpm, motor vibration 12 Hz, total packed goods weight, temperature of the motor 70, predict probability.